Hi, my name is Ashley Bell, and I'm going to be teaching a 6th grade lesson on the scientific method. Good morning, class. We're starting off our science lesson today with a video to help us review the scientific method. Here we go.
What's all this, Mia?
Don't touch them! That's part of my experiment.
Experiment? What are you, a scientist now?
I am using the scientific method to see whether or not hummingbirds are attracted to the color red.
Can't you just keep track of which bird feeder they eat from the most?
That is kind of what I'm doing. By going through each step of the scientific method, I can test my theory to see if it's true or false. The scientific method is the process that scientists use to investigate the world. I put a red...
Alright, I'm going to stop it just for a second. These steps are very important. Make observations, form hypotheses, design an experiment, gather data, draw conclusions. Make sure these are some of your vocabulary words. Make sure you're paying attention as we watch this movie. After it's over, we're going to go over them in more detail, but those are what you're listening for.
feeder and a blue feeder up in the tree, and after watching for a few days, I observed that most of the food was gone in the red one. That's the first step of the scientific method, observation.
Well, doesn't that observation mean that hummingbirds like the red feeder better?
It could mean that. Once scientists make their observations, they start to ask questions about what they've seen. Like, why was the food in the red feeder gone first? Then they come up with a hypothesis that might answer their question.
Who?
Hypothesis. That's science lingo for prediction, or a temporary answer that you can test. My hypothesis is, hummingbirds are attracted to the color red.
So how do you test if your hypothesis is correct?
That's the next step, designing experiments. An experiment is a scientific test to try out a theory, or to see some effect. To test if hummingbirds really are attracted to the color red, I hung up 4 different colored bird feeders with exactly the same amount and type of food. When scientists design an experiment, they try to control every little variable, things that might affect the outcome.
That's why you told me not to touch. You were worried I'd disturb the variables.
If you don't control the variables, it's not a fair test. If you touch one of the feeders, the birds might not eat from it because you touched or spilled it, not because it isn't red.
Sounds a little nitpicky, Mia.
Scientists can never be too careful. It's also...
Is that what's in that notebook?
Yep, but it's also where the next step of the scientific method comes into play. Gathering data.
Data is information, right?
Right. I took a picture of each bird feeder every morning and night for a week. I pasted the pictures in this notebook and labeled the time and date and wrote down which feeder had the most food missing each day.
Why'd you do it for a whole week?
To make sure the results were the same every time.
Were they?
Let's draw our conclusion and find out. Drawing a conclusion is like the aha moment. It's when you look at your data to see what it tells you.
Let's see those pictures you got. That's your data, right?
Yeah, I've carefully organized the pictures into a chart to show my results. We need to ask, does our conclusion fit our hypothesis? Our data shows us that they ate the food in the red feeder the most. Our conclusion supports our hypothesis. Hummingbirds are attracted to the color red.
But why are they attracted to the color red?
Why is the final step in the scientific method. Keep asking questions.
I guess that's why scientists keep on finding out more about the world. They watch the world around them, develop hypotheses about how things work, and test their hypotheses with cool experiments. Once the experiment is done and the data is collected, scientists can draw conclusions about their hypothesis and find out if they were right or wrong.
Right. Observations, hypothesis, experiment, data, conclusion. That's the scientific method behind the madness.
All right, well, let's look further into these. Let me just grab the lights. Okay, let's go in a little more detail on exactly what is science. Science is a process that uses observations and investigations to gain knowledge about events in nature. Scientific explanations help us to understand what is going on in the natural world, things going on around us. Sometimes explanations must be modified if new technology or new information is discovered. Let's stop here for a second. I want you to go heads together, bottoms up with your team and discuss a time that you can think of where new technology changed our way of thinking, an explanation. All right? Heads together, bottoms up. Go. All right, right, boys and girls, thank you. I heard some great ideas. Let's continue. Scientists learn new information by performing investigations. We're actually going to be scientists today and perform our own investigation. Here's an example. How do you know if you have allergies? Observations, experiments, modeling. Observe how you act around, for example, our little peanut guy. If your face starts swelling, you know there's a problem. Okay, you experiment. Was it the peanuts or was it something else that was going on? Which I don't recommend trying that particular one. All right, what we're going to focus the most on today is the actual scientific method. It's an organized set of investigation procedures. Excuse me. All right, our first step is to state a problem. You're asking a question. What is it that you want to fix? Okay, your second step is to gather information. This is your research step. This is when you learn as much as possible about your topic and gather background information. It could be from internet, it could be from books, it could even be from other scientists. Your third step is to form a hypothesis. You've heard this word a lot. I want you to turn and tell your shoulder partner, what do you know about a hypothesis? Go. I heard lots of correct answers. You're right. It's an educated guess. It's based on your knowledge and observations that you see. It provides a direction to the experiment. Now here's the thing. Does a hypothesis always have to be correct? No. Your experiment is designed to either prove it or disprove it. All right, step 4, gather all your materials. You need to have everything before you get started. You also need to list your procedures. What's your first step, what's your second step, everything you're going to be doing. For example, our board has the steps for making a hamburger. Step 1, get out 2 slices of bread. Step 2, put mustard on 1 slice. Step 3, place a hamburger on the patty. Step 4, put cheese. Step 5, add pickles. Step 6, eat. You can't do step 6, eat, until you've made the hamburger. Procedures have to go in order. All right, 6, list the results. While you're doing the investigation, you collect data. The results should be in written form so they can be analyzed. This could be in paragraphs, this could be tables, this could be graphs. Your last and final step is drawing conclusions. So we've asked a question, we've gathered all the information and materials we need, we've conducted our experiment, and we have our data. Now it's time to take a look at the data and draw a conclusion. You look at the results and compare them with the problem. Was the hypothesis correct? Why or why not? Okay? Explain, very important. So in review, here's all the steps together. Step 1, state the problem. Step 2, gather information. Step 3, form a hypothesis. Step 4 and 5 kind of go together. Gather the materials and list the procedures. Step 6, analyze the results. Step 7, draw your conclusion. And this is where you state whether your hypothesis is correct or not. Well, now it's your turn, okay? We're going to be completing a lab that has us use all of these steps. It's going to be called How Many Drops of Water Will a Coin Hold? All right, boys and girls, I want you to turn and talk to your partner about how we could possibly design an experiment that would measure this. Go. Great ideas on how this experiment can be conducted. Here's the way we're going to do it today. Now, before I get into this, I want you to keep in mind something. Scientists collaborate with each other, okay? You're going to be working with a team of scientists to complete this investigation. And throughout this, you're going to be sharing with other teams. It's a very important skill. You're going to be sharing your results, and you're going to be comparing and contrasting different things in the experiment because not all of them might be the same, and you're going to figure out why. All right, let's take a look at this. This is you're a scientist. Apply the scientific method as you work through this lab. The purpose is to show how changes in your procedures can yield different results. Here's the materials you're going to need. 2 different coins, paper towel, eyedropper, water, lab sheet. Procedure. You're going to begin the scientific method sheet and continue it as you work through the lab. Okay, this is the very first thing that we're going to be doing. You're going to get a flow map that looks like this. If you notice, these steps of the scientific method are listed here that we just did on the PowerPoint. Problem, research, hypothesis, experiment, which this is your materials and, yes, procedures. Analyze data, draw conclusions. As you go through each step, you're going to be writing about it. We already have our problem. Okay, what are we trying to solve? That's right. How many drops of water will a penny hold? You're going to keep going through until you have everything filled out. Okay, this is what you're going to do while you're conducting your experiment. All right, after that, you'll have a reflection sheet to fill out. All right, you're going to put 2 different types of coins on a paper towel. Let me grab my paper towel and my coins. You're going to use an eyedropper to put water on the coins, and you're going to count them as you go. As you do this, here's another sheet you're going to have to fill out. There's a first trial and a second trial. You're going to say, what coin is it? Did you use heads or tails? How many drops of water did you hold? Were you close to the coin when you dropped or far away? And did you drop it fast or slow? If you notice, there's a lot of ways that you can change how you drop water on a coin. There's all groups will end up doing it different. This is the only direction that I'm giving you. Okay, you're going to put a coin. Notice I'm put mine on tails, but that doesn't matter. You're going to use a dropper. And water in our measuring cup. You're going to fill the dropper with water by squeezing and letting go. Okay, and then you are going to count how many drops until it overflows. In this particular case, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We're still spreading out. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, we're getting close, 23, 24, 25, 26, 27, 28. It took 28 drops to overfill. All right, so then I'll fill out my coins, and then I'll take, that was with a nickel, so then I'd repeat with a penny, and I'd fill out my information. Okay, and then you're going to do a second trial. You're going to change some things up. Like maybe if you did heads, you're going to go tails. Or if you were close to it, you're going to go far away. And you're going to figure out if things change. But don't forget, you have the flow chart you have to fill out in between. All right, boys and girls, any questions? All right, well, let's get your materials passed out and get started. Very good job. I saw lots of collaboration. Now's the time when we're going to share. Okay, I want each team to have, we're going to number off them befores, okay? All my ones from one group are going to meet together. All my twos, all my threes, all my fours. You're going to share your data. You're going to see what you did the same and what you did differently. All right, go ahead and number off, okay? Split up and go ahead and discuss with your experiment how you differ from other teams. Okay, so that's your goal for the end of the period. Get the lab sheet done, and then before you leave, you need to get your ticket out finished. All right, any questions? All right, you may go.